Hi, welcome to this Data Science Dojo beginner tutorial on getting started with Python and R for data science. In this beginner tutorial, we'll take you through some common Python and R packages and libraries used for machine learning and data analysis, as well as go through a simple linear regression model. We'll also help you set up Python and R on your Windows, Mac, or Linux machine, run your code locally, and push your code to a Github repository. So let's get started with installing Python and R. To install Python on a Windows machine, we first need to check if our machine is 64-bit or 32-bit, as this will determine the appropriate Python program to install. To do this, search for About Your PC, and you'll see if your machine is 64-bit or 32-bit. In my case, it's 64-bit. Next, in your web browser, type python.org/downloads/windows and scroll down to the version of Python you wish to download. In my case, I'll choose the latest version for 64-bit executable installer. You can go with the default installation, or you can do a custom installation to include optional features such as pip, or you can specify your path directly under C, so it's easier to locate your Python program later on. And just click install. Once Python has installed on your computer, you'll need to add Python to your path to be able to run Python scripts in a directory or folder. Download Git for Windows to set your path and run the Python command. The command using this program are basically the same when using terminal in Mac or Linux. Alternatively, for Windows, you can use the default command prompt by searching cmd. You can also set your local path by searching environment variables and setting your path there. Here's an example of a Python script saved in my Documents Project 1 folder. Using a text editor of my choice, such as Notepad++ to write my Python code, I save my file as a .py file. Then, I open my terminal, which is in C, Program Files, Git cmd. I navigate to Documents Project 1. And I set my local Python path. So we'll set this up permanently using a bash rc file with the path to my Python program directly under C. Now, I simply type py, followed by the name of the file and extension. If using Python 2.7, just type Python followed by the name of the file and extension. If we were to hit enter to run this, it would produce the output of my code, which is predicted heights using a linear regression model. The final part of this Python Windows setup is installing pip to be able to easily install Python packages and libraries. Pip might not have come with your installation if you didn't customize your installation, or it might not be installed in an older version of Python. So to get pip, type in your web browser bootstrap.piper.io/get-pip.py and right-click to save in your Python program folder, and then run the command python get-pip.py. So my Python program's under C. Moving on to installing R for Windows, simply type in your browser cran.r-project.org/bin/windows/base and select the 32 or 64-bit. Once it is downloaded, press OK and click Next to All. Once R has installed on your computer, you can simply open the program on your desktop and start typing R commands or code. I recommend you to download RStudio, as it just makes the process of editing and debugging your code easier. Otherwise, you're welcome to use the R command line. To save an R file, click on File, File History, And this will save your code so you can run it later if you wish. To set your path or working directory, just simply type set wd, followed by the path to where you would like to store your R files locally. You might need to use double backslash for Windows, as Windows understands this to mean separators in the path. Now, let's install Python on a Mac. Go to Mac Terminal in Finder, Applications, Utilities, and now we're going to install command line utilities Xcode, as this will help with the installation. So type Xcode -select --install. Click install and agree. Now we're going to use Homebrew to install Python. So type /usr/bin/ruby, and we're going to use curl. And we're going to type the URL to Homebrew on GitHub. Press return. Enter your password if need be. Next, add the path. So we will create a bash RC file to permanently add the path. If you get an error message stating cannot write to path, try the sudo chown command accompanying this video. All commands can be copied and pasted as they accompany this video. Next, we'll install Python, so just brew install Python, or Python 3 if using Python 3. We'll also add this to our path. So we'll create another bash RC file. Now to check if pip is installed as part of your Python program, simply type which pip, and it will show you the location where your pip is installed. And if you want to check out the version, just type pip-v and it will show you which version of pip you've installed. As mentioned, pip is useful for easily installing Python packages and libraries. Moving on to R, to install this on a Mac after installing Homebrew, simply type brew, tap, homebrew/science. And then type brew, install R. To open the R command line, simply type R and enter. Now let's install Python and R on Linux. I'm using Ubuntu. Later versions of Ubuntu might already have Python installed, but I'll take you through the process anyway. So open your terminal. Okay, now we're going to type sudo apt-get install Python 3.6 or 2.7. Now we're going to type sudo apt-get install python-setup tools. Lastly, install pip to easily install Python libraries and packages by typing sudo easy_install pip. To install R on Linux, simply type sudo apt-get -y install r-base. Now type uppercase R and enter to open the R command line. Now that we've got the setup and installation part of this tutorial out of the way, we can now move on to more fun stuff. Let's have a quick play with some data to get you familiar with some key data analysis and linear regression concepts, as well as basic scripting for this. I'm going to go through an example of a simple linear regression in Python and R using simulated data on people's height in centimeters and their weight in kilograms. The model is based on a formula which can be produced using Python and R functions that gives a predicted outcome or estimated y value given a certain x value at a certain constant and slope. Here's what's called the regression line. I like to think of it as a line of predicted values. Along the x-axis, for a given x value, the line predicts the y value to fall about here in height. The actual y values are slightly above and below the line, but the model is generalized enough to take into account where most cases would probably fall. The formula gives a constant value here, which we add this to a given x value multiplied by a given coefficient or slope. The constant means when x is at 0, y is at this value. And the slope means for every 1 unit increase in x, y increases by this number of units. So we can use this formula to plug in any new x value of a person's weight to predict their height or y value. Of course, there are many other factors, not only weight, that could influence a person's height. Hence, we're just looking at a very simple model to get started with. To implement linear regression in Python, we first need to install a few commonly used packages. We'll open our terminal and install sklearn for modeling. If using Python 2.7, just type python-m pip install. Now we're going to pip install pandas for data importing. We'll also install matplotlib for plotting. The last package we need to install is just scipy. Next, go to your text editor and save a new Python file in Documents Project 1 or a folder of your choice. So I'll just call my file lm_model, save it as a Python file. Also, don't forget to cd into this folder in terminal so you can run your script later. Now we're going to import these packages at the beginning of the script when it runs. So at the top of the file, we'll type from sklearn import linear model, so our linear regression tool. We're also going to import data frame from pandas. We also want to use pandas as PD. And we'll just use it as pandas. And we want to import matplotlib and use it as PLT. Now we need to read in our data, which you can download as part of this tutorial and save in your current folder. We'll use the pandas read table function for this. So we'll put our data in a variable and we'll just call it input data. And we'll use the read table function. And we'll give the data file name an extension in our folder. It's comma separated as it's a CSV file. And we have headers and they start at line 0. And we'll give our X and Y headers specific names. This automatically infers the data types for each column too. Before applying a linear regression model, let's plot the data using matplotlib's plot function to see if the data naturally follows a linear pattern and a normal distribution, as linear regression is not appropriate or useful for data sets that don't follow this assumption. So we'll use a scatter plot. And we're just plotting weight versus height. So weight is on our x-axis and height is on our y-axis. We'll need to show this graph so it can render on our screen. Now save and run the script. As we can see, the data is linear and follows a normal distribution, making linear regression appropriate to use on these data. Now we'll define our x predictor variable weight and our y outcome variable height. So we'll use PD as pandas, and we'll use the data frame function. And we'll use weight as our predictor. And we'll make height our outcome variable. Now we'll fit a model to the data using the fit function and use this to predict height given weight. So we're using a linear regression model. And we'll fit the model to the data. We can now compare the first, say, 6 predicted values using the predict function with the actual height values to see if they're on par. So first we're going to get all the predicted values. And we're going to use our predictor variable to predict the outcome. And we'll just print some subheads to differentiate the list of predicted values from the actual. And we'll have a look at the first 0 to 6 predictions. And we'll compare with the first 0 to 6 actual values. Alright, we'll save and run the script. A quick eyeball of the first few predictions with the actual shows the model was not far off the mark, which is good. However, to properly assess a model, we can use measures such as R-squared, which is the percentage of explained variance. So we'll go back to our script, and we're going to use the score function to get the R-squared. And we want to print this, obviously. Now we're just going to comment out the above lines as we no longer want to view these. We'll save and run our script again. As we can see, our high R-squared shows the model explained most or nearly all of the variance, which is good. However, relying solely on R-squared is probably not good enough when assessing and measuring a model's predictions. Sometimes it can be misleading to look at the R-squared, but the course will go through other measures you can use. To perform the same analysis in R, we'll first install a commonly used R package, ggplot2, which is used for effectively visualizing and analyzing data. I'll select a crane mirror that's close to me. We need to load ggplot2 whenever we want to use it. We'll read in our data using the read table function. We'll put our data in a variable. We use read table. We'll give it our file in our current working directory. It's comma separated. And we do have headers, and we'll just use the default header names X and Y. This automatically infers data types too. We'll also attach our data frame so we can refer to column headers or variable names without having to refer to the name of our data each time, making this more convenient. Now we'll plot the data to see its normal distribution, but we can also use ggplot2 to plot the regression line or the line of best fit. So we'll plot our X and Y, which is weight and height. And in the smooth function, we'll specify a linear model. As we could see before, the actual heights are close to the predictions or the line. Implementing a simple linear regression in R is quite easy using the LM function. Now, to see the first few predictions of height, we'll use the predict function. We first need to get all of the predictions. And we're just going to print the first few to have a quick look. So the first 0 to 6. And we'll compare with our actual values. As seen before, for the first few cases, the predictions are pretty close. To print the R-squared or percentage of explained variance for assessing the model, we'll use summary. As seen before, it explains nearly all the variance, but it's a good idea to also look at errors or other measures for this. Finally, now that we're finished, we'll detach our data. In the last part of this tutorial, we'll push our code to a GitHub repository so you can share your code publicly or store it privately if you wish. You can create a GitHub account for free. You can also follow Data Science Dojo to clone or access a copy of the code provided as part of the course material. Once you have created an account, add a new repository without initializing it yet via the GitHub website. The instructions to push your code to GitHub are on the website, but I'll take you through the process anyway. First, open your terminal and cd into your current project directory, and you'll need to configure your username and user email. Now configure your username. We'll initialize our project directory as our Git repository. Then we'll add all files in our project folder. We're not pushing it live yet, it's just selecting the files. Commit your files to track the first submission with the message, should you wish to publish updates later on. So I'm just going to say first go at implementing simple linear regression. As you can see, all the files in Project 1 folder are there. Now we're going to give the URL of our main repository, so go to the main page of your GitHub repo. And copy the URL. And we're going to paste it into the terminal when adding a remote repo. Finally, we're going to push our code to the repo in GitHub master branch. Now, if you have a look at your GitHub repo, you can see all your files are there. All the work we have done in this tutorial is here. Alternatively, after initializing your GitHub repo via the site, you can simply drag and drop your project folder onto the main page of your repo. Now that you've gone through the basics, you should feel ready to dive into the course and gain a deeper and wider understanding of data science. You know how to set up Python and R in your machine, how to do basic scripting for reading and visualizing data, how to apply a model and assess it, and now you can share your hacks and projects on GitHub. The data used in this tutorial, the coded examples, the commands, the URLs to programs, and so on, are all accompanying this video. My name's Rebecca Merritt. Feel free to reach out to me by commenting on this video. I'm more than happy to help you get ready before you start your course. Thanks for watching and happy analyzing!